everyone, and welcome back for another deep dive.
Yeah.
This time we're going all in on minds, brains, and machines.
Oh, this is a good one.
I know, right?
Really fascinating stuff.
We've got some pretty big questions to unpack here, like, can a machine ever actually think like a human?
Oh, that's a classic.
What is consciousness, really?
Mm.
And do we actually see the world as it really is? I mean, do our brains just make stuff up?
All the time.
Yeah.
Yeah, I think so.
Crazy.
It's going to be fun to dive into all this.
I know, we've got some really cool exhibits to explore today that I think will make you question everything.
Yeah, for sure.
So to kick things off, let's rewind the clock all the way back to 1619. Can you picture this?
Uh-huh.
We've got René Descartes.
Oh, yeah, I love Descartes.
He's like the godfather of modern philosophy. And he's on this quest to find absolute certainty in knowledge, like something as solid as math, you know?
Yep.
But here's the thing.
What's that?
The spark of inspiration hits him.
Where? At his desk.
Not in some stucky library.
Oh, tell me.
It comes to him in a dream.
Whoa, that's pretty cool.
I know, right?
That's kind of wild.
It's like the father of reason finding his breakthrough in the land of dreams.
The irony.
Total irony, right?
So what was the dream?
Well, he had these dreams that showed him two books.
Okay.
One was a total mess, like a jumbled up representation of how chaotic knowledge was back then. And the other was like this perfectly unified volume of all the sciences. And get this, it was envisioned as poetry.
Oh, wow, that's beautiful.
Right.
Even for a rationalist like Descartes, it seems like imagination was super important.
Totally.
And these dreams, they actually led him to develop analytical geometry, connecting algebra and geometry, giving us the X and Y axes we still use today.
Oh, so that's where those came from.
Pretty much.
That's awesome. And of course, we can't forget his famous line, I think, therefore I am. That came from the same quest for certainty.
Yeah, I love that quote.
But this quest also led him down another path. The idea of Cartesian dualism.
Dualism, oh yeah.
Yeah, so basically, dualism is saying that the universe is made of two completely different things, physical stuff and mental stuff.
Your body versus your mind.
Exactly.
Classic problem.
So like your body's physical, right?
Right.
But your mind isn't.
They're almost like separate entities?
Yeah, but then that brings up a whole other question.
No, Jesus.
How do they even interact?
Yeah, the mind-body problem.
Exactly.
Always a tricky one.
Like if my mind and body are on two totally different teams, how does my decision to, let's say, grab a cup of coffee actually make my arm move?
It's weird to think about.
Right.
Yeah. I'm like mad.
It's a total head scratcher.
Yeah, fiddly.
But okay, let's shift gears a bit. Ready for Exhibit B?
Oh yeah, what have we got?
We're going to look at a real-life brain that caused quite a stir.
Okay.
Albert Einstein's brain.
Whoa. Seriously.
Yes.
That's amazing. What's the story there?
Okay, so the story behind Einstein's brain is a little unusual.
I bet it is.
So after Einstein passed away in 1955, the pathologist who did his autopsy, his name is Dr. Thomas Harvey, he decided to remove and keep Einstein's brain for research.
Wait, hold on.
What?
He just took it.
Yeah.
Wow, that's bold.
I know, right?
You can't just take someone's brain.
Apparently you can.
I guess back then.
I guess so. And you want to know where it ended up?
Where?
In a cider box.
What?
A cider box under a beer cooler.
No way. Seriously.
I'm serious.
That's crazy.
It's like one of history's greatest minds ending up in the most random place.
It's a good trivia question.
Right.
So what did they find out from studying it? Did they unlock the secret to genius?
Well, surprisingly, Einstein's brain wasn't actually bigger than average.
Oh, really?
Yeah.
I always thought it would be huge.
Right.
So what was different?
They did find some interesting differences, like his inferior parietal lobe, that's the part of the brain linked to math and visual thinking, it was 15% wider than normal.
Wow, so maybe that played a role in all those groundbreaking thought experiments he's famous for.
That makes you wonder, right?
Like imagining riding a beam of light.
Exactly.
Yeah.
But wait, there's more.
Oh, no.
They also found that a part of his brain that's potentially linked to speech was missing.
What? So he was missing a part of his brain.
Yeah.
Wow, and he was still a genius.
Well, it's incredible, right?
How did that affect him?
Well, some people think that might be why Einstein was slow to start talking as a kid,
Oh, interesting.
and that he always seemed to prefer thinking visually.
Makes sense.
This case shows how our brains can be wired differently.
For sure.
And it really illustrates this concept of brain plasticity.
Brain plasticity.
Yeah, it's the idea that our brains are always changing and adapting.
So it's not just a fixed thing.
Nope, it's constantly evolving.
That's so cool.
I know. All right, so We've seen how even geniuses have brains that are wired differently. Now, you ready for a little time travel adventure?
I'm always ready for time travel.
Awesome. Let's jump back to the 1800s
Okay.
and meet Charles Babbage.
Charles Babbage. Okay.
This guy was brilliant.
What did he do?
He was a mathematician and inventor who essentially designed the first computers.
No way. Back in the 1800s.
Yeah, can you imagine?
What do they look like?
Well, picture giant steam-powered machines.
Whoa. Steampunk computers.
Right. He called them the difference engine and the analytical engine.
I can't even imagine those clunky machines crunching numbers back then.
It's wild to think about, right?
Yeah, especially compared to our sleek smartphones today.
I know. Babbage was way ahead of his time.
So what could these machines actually do?
Well, the difference engine was mainly for calculating mathematical tables,
Okay.
but the analytical engine,
What about that one?
that was the real game changer. It was designed to perform any mathematical calculation you could throw at it.
Wow, that's like the granddaddy of all modern computers.
Exactly.
It makes you wonder,
What's that?
what if Babbage had actually succeeded in building these machines?
Oh, that's a great question.
What if the digital revolution happened a whole century earlier?
Whoa, that's a mind-blowing thought, like something out of a steampunk novel.
Right.
How would our world be different if we had steam-powered computers running the show back then?
I don't even know where to begin.
I know.
Actually, you know what's funny?
What?
The authors, William Gibson and Bruce Sterling,
Oh, yeah.
they actually explored that idea in their novel, The Difference Engine.
Really?
Yeah, they imagined this whole alternate history where Victorian society is totally transformed by these machines.
Wow. Might have to check that book out.
It's a good one.
So Babbage's vision of a machine that could perform any calculation, it takes us back to that fundamental question, right?
Oh, yeah. Could a machine ever truly think like a human?
Exactly.
And it brings us back to Descartes' dualism,
Full circle.
right back to the beginning.
Remember how he said the mind and body are separate?
Yeah.
Well, that idea has faced some challenges over the years,
For sure.
especially the whole question of how they interact.
That's the tricky part.
Right.
It's hard to wrap your head around it.
Yeah, like if my mind is non-physical, how can it possibly influence my physical body?
It's like trying to mix oil and water.
Exactly.
So are there other theories out there that try to explain this puzzle?
Oh, yeah, there are quite a few. One is called epiphenomenalism.
Oh, the phenomenalism.
Yeah.
Okay, I'm listening.
Basically, it says that mental events are just side effects of physical processes in the brain, like your feeling of joy. It's not really causing anything. It's just a byproduct of what's happening in your brain.
So it's kind of like a shadow. It's there, but it doesn't actually have any power to do anything.
Yeah, that's the basic idea. Then there's occasionalism.
Occasionalism.
Hmm.
What's that one?
This one's a bit more spiritual. It's the idea that God is constantly making sure that our mental and physical events are in sync.
So it's like God is the ultimate puppeteer, ensuring our minds and bodies are always on the same page.
Exactly.
I like that analogy.
But these are all still dualist viewpoints, right?
Right.
Then we have monist theories. Yeah, which argue that there's actually only one type of stuff in the universe.
Oh, interesting.
Like idealism, which says everything is ultimately mental, and then there's the extreme version of that, solipsism, where the only thing you can be certain of is your own mind.
So basically, I think, therefore I am, and you might not be.
Right.
That's a pretty wild idea.
It is. But then on the flip side, you have materialism, which says that everything is ultimately physical.
Okay, so it's like the opposite of idealism.
Exactly.
Interesting.
One version of this is reductive materialism, which suggests that all mental states can be boiled down to physical processes in the brain.
So my craving for pizza is just a specific pattern of neurons firing in my brain.
That's what reductive materialism would say. There's also a more specific version of this called type identity theory, where specific mental states are identical to specific types of brain activity.
But then wouldn't that mean that any being with a similar brain structure would experience the same things?
That's a good point.
Like, what about an alien with a completely different kind of brain? Could they still feel pain?
Yeah, that's one of the challenges to reductive materialism.
That's a good question.
There's also eliminative materialism, which goes even further. It argues that our everyday understanding of mental states is just plain wrong.
Wait, so you're saying things like beliefs, desires, and sensations don't even exist?
That's the radical claim of eliminative materialism.
Whoa, that's a lot to
I
process.
know, right?
Seems like we need a new way of looking at things, something that goes beyond both dualism and these more traditional forms of materialism.
I think you're right, and that's where functionalism comes in.
Functionalism.
Yeah, it offers a fresh perspective on the mind-body problem.
Okay, I'm intrigued.
Mm.
Tell me more about this functionalism thing. What's it all about?
Well, instead of getting hung up on what mental states are made of, functionalism focuses on what they do, their function or their role.
Interesting.
Think of it this way. Your brain is like a computer, and
Yeah.
your mental states are like software programs.
So it's like the difference between hardware and software. The same program can run on different types of computers.
Exactly.
So in the same way, different brains could give rise to the same mental states.
You got it.
I think I'm starting to get it.
The key insight here is that anything, whether it's a brain, a computer, or even some hypothetical alien, could have a mental state.
As long as it performs the right function.
Exactly.
Okay, that's pretty cool.
Right.
But how do we actually experience these mental states? I mean, we often talk about having this inner theater where our perceptions play out. But is that really how it works?
That's a great question.
Right.
It's so natural to think of our minds as having this inner screen where we see and experience everything.
Like a little movie theater in our heads.
Exactly.
But there are actually some pretty compelling arguments against this idea.
Oh, really?
Yeah.
Like what? I'm curious.
Well, for one thing, the order in which we experience events doesn't always match the order in which our senses receive information.
That's interesting.
There's a classic experiment called the cutaneous rabbit that shows this.
The wet rat.
The cutaneous rabbit, it's C-U-2-A-N-E-O-U-S.
Cutaneous rabbit. Okay.
Yeah. So imagine a series of taps on your wrist.
Okay, I'm imagining it.
You actually experience them as a rabbit hopping up your arm, even though the taps don't physically move that way.
Wait, what? Really?
It's true. It's a weird perceptual illusion.
That's so strange.
It is.
So our brains are kind of editing reality to create a smoother experience.
Exactly. Our brains are constantly filling in the gaps and making sense of the information we receive.
Wow, our brains are sneaky.
They are. And another challenge to the inner theater idea is that our mental images aren't as detailed or complete as we often assume.
Okay, I see what you mean.
Like, try picturing a pirate in your mind.
All right, I've got my pirate.
Okay, do you know exactly how many buttons are on his coat? Or the specific shade of his eye patch?
Good point. My pirate is a little blurry around the edges.
Right. Our mental images are more like sketches than high-definition photographs.
It makes sense.
Plus, the whole idea of an inner theater is heavily influenced by our culture and history.
Oh, I hadn't thought about that.
Think about the ancient Egyptians. They believed the heart, not the brain, was the seat of consciousness.
Wow, really?
Yeah, so our current understanding of the mind is shaped by the way we think about the world.
It's like our culture influences our very understanding of ourselves.
Exactly.
Okay, so if there's no inner screen, how do we actually experience the world? How do our senses work, and what are we really perceiving?
That's the million-dollar question.
It feels like we need to redefine what perception even means.
I think you're right.
So where do we even start?
Well, one theory we haven't touched on yet is naive realism.
Naive realism.
Yeah, it's basically the idea that we see the world exactly as it is. What you see is what you get.
That seems pretty straightforward, right?
It does, but there's a catch.
Uh-oh. I knew there had to be a catch.
Perceptual illusions show us that our senses aren't always reliable.
Like optical illusions.
Exactly. They trick our brains into seeing things that aren't really there, or not seeing things that are.
I love optical illusions. They're so trippy.
They are. But they also reveal something fundamental about how our brains work.
What's that?
They show us that our perception isn't just a passive process of receiving information.
It's more active than that.
Much more. Our brains are constantly interpreting and constructing our experience of the world.
So it's not just about what's out there, it's about how our brains make sense of it.
Exactly. And one way our brains do this is through inference.
Inference.
Yeah, our brains are constantly making educated guesses about the world based on the information we receive.
So it's like our brains are detectives piecing together clues to figure out what's really going on.
That's a great analogy. And they're remarkably good at it most of the time.
But sometimes our brains get it wrong.
Sometimes, yeah.
Right.
Like with optical illusions.
Right.
Or think about color perception.
Okay.
An orange under green light will appear gray, even though it's still technically orange.
Wait, really?
Yeah, it's because our brains are taking into account the surrounding lighting conditions and adjusting our perception accordingly.
So it's not just about the color of the object itself, it's about the context.
Exactly. And another example is the Shepard tone illusion.
Okay, I'm not familiar with that one.
It's an auditory illusion where a sound seems to continuously descend in pitch, even though it's actually looping.
Whoa, seriously, that sounds crazy.
It is. You can find recordings of it online. It's pretty mind-bending.
I'll have to check that out.
So if we're not directly perceiving the world as it is, what are we actually perceiving? What's going on in our brains?
Yeah, it's a good question. What are we actually seeing then?
Well, one idea is that we're perceiving sense data, raw, uninterpreted sensory information, like patches of color or simple sounds.
So it's like our brains are getting these basic building blocks of sensory information.
Exactly. And then, based on that data, our brains construct a model of the world.
It's like our brains are taking these bits and pieces of information and piecing them together to make sense of everything?
Precisely. But even this view has its challenges.
Really? Like what?
Well, the concept of inference seems a bit too deliberate and cognitive to account for the immediacy of our perceptions.
What do you mean?
Like, when you see a car speeding towards you, you don't consciously think, okay, those are patches of color moving in a certain pattern, so that must be a car about to hit me.
Yeah, there's no time to think in that situation. It's all about instinct.
Exactly. Our perceptions feel immediate and effortless, not like we're constantly making complex calculations.
So what's a better way to understand how this works?
Well, some philosophers argue that we need to move beyond the idea of perception as simply processing sensory data.
Okay, so what's the alternative?
They emphasize the aboutness of perception.
Boundness.
Yeah, the idea that our experiences are always directed towards something.
I see. So when you see a car speeding towards you, your perception isn't just about the visual data.
It's about the car itself, its movement, and the potential danger.
So my perception isn't just passive, it's loaded with meaning and intention from the start.
Exactly. You're not just seeing, you're seeing something.
Okay, that makes sense.
And there's even neuroscientific evidence to back this up.
Oh, really?
Yeah, cases of agnosia, where people have trouble recognizing specific categories of objects, really highlight this.
Like prosopagnosia, the inability to recognize faces.
Exactly. They can see the features, but they don't process them as a face.
It's like the meaning is missing.
Precisely.
Mm.
It shows that perception isn't just about processing sensory data. It's about recognizing entities, understanding their significance, and making sense of the world around us.
So our brains aren't just taking in information, they're actively interpreting it and giving it meaning.
Exactly. And this leads us to another fascinating perspective on perception, the evolutionary approach.
Okay, so how does evolution play into all of this?
Well, the evolutionary perspective suggests that our perceptual systems have been shaped by natural selection over millions of years.
Survival of the fittest senses.
Kind of. Our senses have evolved to help us survive and reproduce in our specific environments.
That makes sense. Like, certain animals have developed super specialized senses, like echolocation in bats or the ability to see ultraviolet light in bees.
Exactly. Their senses are finely tuned to their specific needs and the challenges of their environments.
So our senses aren't just random, they're the result of millions of years of evolution, honing them to help us navigate the world and stay alive.
Precisely. And this goes way beyond our basic five senses. Think about blind sight.
Blind sight, where people can react to things they can't even consciously see.
Exactly. It suggests that there are unconscious pathways in the brain that process visual information even when we're not aware of it.
It's like our brains are doing all this work behind the scenes, constantly processing information from our environment to help us make sense of things.
Exactly. And this evolutionary perspective highlights how deeply intertwined our minds and bodies are with the world around us.
It's like we're not just separate individuals, we're part of this larger web of life, constantly interacting and adapting to our environment.
I like that way of putting it.
So it seems like understanding the mind means going beyond just the brain itself.
I agree.
We have to consider how our brains interact with our bodies and the world around us.
Exactly. This leads to a really cool concept: the mind in the world.
The mind in the world?
Yeah, it's a fascinating idea that challenges the traditional view of the mind as being solely contained within the brain.
Okay, I'm intrigued. Tell me more about this mind in the world concept. What does it mean?
Well, think about how we interact with our environment.
Yep.
We constantly rely on external tools and resources to help us think and act.
Like using a calculator to do math or writing down notes to remember things.
Exactly. These tools become extensions of our cognitive abilities,
Hmm.
allowing us to perform tasks that we wouldn't be able to do on our own.
It's like we're outsourcing some of our mental processes to the world around us.
Exactly. And this leads to a pretty radical question.
Oh, what's that?
Could these tools, in a sense, become part of our minds?
Wait, are you saying our minds could extend beyond our brains?
That's the question some philosophers are asking.
Whoa, that's a wild thought.
It is. Imagine someone named Otto, who has a severe memory impairment.
Oh.
He relies on a notebook to function in the world, meticulously writing down everything he needs to remember. Appointments, directions, facts.
So he's basically outsourcing his memory to his notebook.
Precisely. It's essentially his external memory system.
That's fascinating.
Now, imagine someone named Inga, who has a perfectly functioning memory.
Okay, I've got Inga.
She relies on her biological memory to store and retrieve information. So here's the question. Is Otto's notebook, in some way, part of his mind?
That's a tough one.
If it plays the same role as Inga's biological memory, could we argue that his mind extends beyond his brain and into the physical world?
Whoa, that's a mind-blowing idea.
It is, and it challenges our traditional assumptions about where the mind begins and ends.
So our minds might not be limited to our skulls. They could actually incorporate parts of the environment.
That's the claim some philosophers, like Andy Clark and David Chalmers, have made with their extended mind hypothesis.
It's like those tools aren't just extensions of our bodies, but extensions of our minds as well.
Exactly.
And speaking of extensions of our minds, think about how much we rely on our smartphones these days. We use them for everything: communication, navigation, entertainment, even remembering where we parked our cars.
It's true. Our smartphones have become indispensable tools for navigating the modern world.
Could we say that our smartphones are becoming part of our extended minds?
That's a fascinating question to consider.
Right.
As our devices become more integrated into our lives and we offload more and more cognitive tasks to them, the line between our minds and our technology starts to blur.
It's almost like we're all becoming cyborgs, with our minds merging with technology.
In a way,
But
yes.
it's not necessarily a negative thing, right?
Right. It could be seen as a natural evolution of the human mind, constantly seeking new tools and strategies to enhance its abilities.
It's like we're constantly expanding our cognitive horizons.
Exactly. And this raises some really interesting questions about the future of intelligence.
Like,
Well, if our minds can extend beyond our brains, could we create truly intelligent machines by embedding them in rich and interactive environments?
oh, that's a really cool idea.
Right. The traditional approach to AI has been to build disembodied minds, computer programs running in isolation.
But maybe the key to real artificial intelligence is to give these programs bodies and let them interact with the world just like we do.
That's what a lot of researchers are starting to think.
It's like we need to create embodied AI, not just disembodied intelligence.
Exactly. And that brings us back to robotics.
Full circle. We've talked about the history of robots in myths and fiction, but what about the robots of today? What are the possibilities and challenges?
Well, we're seeing robots being used in a growing number of fields: manufacturing, space exploration, surgery.
It's like robots are everywhere these days.
They are, and they're becoming more sophisticated all the time.
So what kinds of things can they do?
They can handle complex tasks, learn from experience, and even adapt to changing environments.
That's incredible.
It is. But there are still some major hurdles to overcome.
Oh, yeah. What are some of the challenges?
One of the biggest challenges is creating robots that can interact with the world in a truly human-like way.
What does that mean exactly?
It means being able to perceive and understand their surroundings, navigate complex environments, manipulate objects deftly, and even communicate and collaborate with humans effectively.
That's a tall order.
It is. And it also means being able to learn and adapt on the fly, handle unexpected situations, and solve problems creatively.
So it's not just about programming robots to follow instructions, it's about giving them the ability to learn and think for themselves.
Exactly. And researchers are exploring different approaches to achieve this.
Like what?
One promising area is developmental robotics, which draws inspiration from how children learn.
Oh, that's interesting. So instead of programming robots with everything they need to know, we let them learn and develop over time, just like kids do.
Precisely. Developmental robots are designed to learn by doing, experimenting, and making mistakes, just like we do.
It's like a baby learning to walk and talk by exploring and interacting with its environment.
Exactly. And this approach has the potential to create robots that are more flexible, adaptable, and ultimately more intelligent.
That's an incredible approach. It could revolutionize the field of robotics.
It could. But this new era of intelligent robots also raises some important ethical questions we need to consider.
Oh, that's right. We can't forget about the ethics of all of this.
Absolutely. As robots become more intelligent and capable, what happens when they start to challenge our assumptions about what it means to be human?
Whoa, that's a deep question.
It is. Will we need to redefine our ethical frameworks to account for the rights and responsibilities of these new forms of intelligence?
It's like we're stepping into uncharted territory.
We are. And what about the potential for misuse? Could robots be used for harmful purposes, like creating autonomous weapon systems or surveillance technologies that invade our privacy?
Those are some serious concerns. It's a lot of responsibility.
It is. We need to make sure we're developing and using these technologies responsibly and ethically.
So it's not just about the science and engineering. It's about having a broader societal conversation about what kind of future we want to create with these technologies.
Exactly. We need to ensure that these technologies are developed and used in ways that benefit all of humanity, not just a select few.
Well said.
These are conversations we need to be having now as we create and deploy these increasingly sophisticated technologies.
It seems like we're on the verge of a whole new era where the lines between minds, brains, and machines are blurring.
We are. And it's an era filled with both incredible promise and potential peril.
It's exciting and a little scary all at the same time.
Exactly. It's a time of great transformation, and it's up to us to shape the future wisely.
It's a lot to take in, that's for sure.
It is.
And it makes you wonder what the future holds.
Oh yeah, the future's wide open.
But hey, while we're pondering these futuristic scenarios, there's some incredible technology already impacting our understanding of minds and brains right now.
That's true.
Have you heard much about brain-computer interfaces?
BCIs.
BCIs, have you?
Oh yeah, I've been following that research closely. It's super exciting.
I've heard the term, but honestly, I'm a little fuzzy on the details.
Okay, yeah.
What are BCIs exactly?
Well, imagine being able to connect your brain directly to a computer, bypassing all the usual pathways of nerves and muscles.
Whoa, that sounds like something straight out of science fiction.
It does, doesn't it?
It's like mind control or something.
Kind of, but it's real, and it's already happening.
So how does it actually work?
Well, it involves implanting tiny electrodes in the brain. These electrodes can pick up on the electrical signals produced by neurons, and then those signals can be decoded and used to control external devices.
So what can people actually do with BCIs right now?
A lot, actually. For people with paralysis or other disabilities that limit their movement, BCIs offer a chance to regain control over their bodies.
Oh, wow, that's amazing.
It is. Imagine someone who can't physically move their arm being able to control a robotic arm with just their thoughts.
Whoa, that's incredible.
And that's just the tip of the iceberg.
Really? There's more.
Oh yeah. Researchers are developing BCIs that allow paralyzed patients to move cursors on a screen, type messages without using their hands, and even communicate by selecting letters with their minds.
It's like giving people a new voice.
Yeah.
A new way to express themselves.
Exactly. It's incredibly empowering technology.
It's mind-boggling to think about the impact this could have on people's lives.
It is. It has the potential to revolutionize how we treat disabilities and improve the quality of life for millions of people.
But what about the rest of us, those of us who aren't facing those kinds of challenges? Could BCIs enhance our abilities too?
Absolutely.
Really?
Imagine being able to download information directly into your brain, Matrix style,
Whoa, that would be wild.
or control virtual environments with your thoughts.
It's like the ultimate virtual reality experience.
Right. Those scenarios might seem like science fiction now.
Yeah, a little far-fetched.
But as our understanding of the brain grows and our BCI technology advances, who knows what the future holds?
It's pretty exciting to think about,
It is.
but I also can't help but feel a little uneasy about it.
Yeah, I understand.
It's like opening Pandora's box, isn't it?
It's a powerful technology, and like any powerful technology, it comes with risks as well as benefits.
What kind of risks are we talking about?
Well, for one thing, there's the issue of privacy.
Oh, right. If our brains are connected to computers, couldn't someone hack into our thoughts?
That's a valid concern.
And what about control?
Yeah, who gets to control this technology? And how do we ensure that it's used for good and not for harm?
Those are some heavy questions.
They are.
It seems like we need to have some serious conversations about the ethical implications of BCIs before they become widespread.
I completely agree.
It's not just about the science and engineering. It's about having a broader societal conversation about what kind of future we want to create.
Well said.
Well, this has been quite a deep dive.
It has. We've covered a lot of ground.
We've gone from ancient philosophy to cutting-edge neuroscience. from the nature of consciousness to the potential of artificial intelligence.
And everything in between.
It's amazing to see how all these ideas are connected.
It really is.
So as we wrap up our exploration of minds, brains, and machines, what are some of the key takeaways you hope our listeners will remember?
Let me think. I guess, first and foremost, I hope they come away with a sense of awe at the sheer complexity and wonder of the human mind and brain. We've come a long way in our understanding, but there's still so much we don't know. And as we develop new technologies like BCIs, we're not just expanding our knowledge of the brain, but also pushing the boundaries of what's possible.
And it's important to remember that technology is a tool. It can be used for good or for ill. It all depends on how we choose to develop and use it.
Exactly. We need to be thoughtful and responsible in our approach to these powerful new technologies.
So, to our listeners out there, keep those minds open, those brains engaged, and those imaginations firing. The journey into the mysteries of the mind is far from over.
It's just getting started.